Hello everyone, my name is Muhammad Afif bin Ismail. You can call me Afif. I will be representing Group 13 for the assignment group of Scientific Inquiry. Today, we will be presenting an article critique. First of all, let's meet our group member. First one is me, Muhammad Afif bin Ismail, can call me Afif. The second one is Muhammad Hilmi bin Wan Omar, can call him Hilmi. The third one is Nabil Qayyum bin Beni Zaidi, can call him Nabil. The fourth is Jared Goh Cheng Yang, can call him Jared. And lastly is Muhammad Akif bin Mu'jad, can call him Akif. Now let's move on to the article's background. So this article is a collaborative work of authors. The name of the authors are Wei Shu, Yuan Wang, Dong Rui Zhang, Zhe Yang, Zhuang Yuan, Yang Lin, Hao Yan, Xin Zhou, and Chao He Yang. The title of this article is Transparent AI-Assisted Chemical Engineering Process, Machine Learning Modeling, and Multi-Objective Optimization for Integrating Process Data and Molecular Level Reaction Mechanisms. So this article explores the universal framework of integration between artificial intelligence, AI, and reaction mechanism. It also explains how to build a database, integrating process data and reaction network data. The emphasis of this article is the development of a hybrid modeling framework that integrates artificial intelligence, big industrial process data, and molecular level reaction mechanisms. Now let's move on to the article's abstract. So for the abstract, this study looks at how to improve chemical process modeling by combining three key elements: the fundamental of chemical principles, the industrial big data, and artificial intelligence, AI. One of the main challenges in this area is dealing with the complexity of reaction networks. To address this, the researchers proposed a transparent AI-assisted chemical process framework. They created a database that merges big data from chemical processes with detailed reaction network data. Then, they used machine learning and multi-objective optimization to improve the process. Then, what are the questions and hypotheses from this research in this article? So, the two questions are how artificial intelligence and molecular level mechanism can be integrated to improve process modeling in FCC. Here, FCC means catalytic fluid cracking. The second question is, what are the economic, technical, and environmental impacts of optimizing FCC processes using hybrid modeling and multi-objective algorithms? For the hypothesis, the researchers claim that integrating AI with reaction mechanism models will provide more accurate and understandable predictions of FCC process performance compared to a standalone AI model. Now let's move on to the methodology.
Hi everyone, I'm Hilmi and I will be representing the next part of our study. Now that we have covered the question and hypothesis, I will be focusing on methodology used in this research. This study introduced a hybrid framework that combines molecular level chemical modeling, artificial intelligence, and real industrial data to improve efficiency operation. Instead of general models, they reconstructed 99 specific molecules from 35 to 175 Celsius fraction range, which made the simulation much more precise. To make the AI decision explainable, they use SHARP, which help identify the most important variables, especially reaction rate, residence times, and catalyst to oil ratio. Then, using a multiple objective optimization algorithm called Mojaya, they were able to balance four goals: increasing LPG and gasoline yields while reducing dry gas and coke formation. Next, result and conclusion. The results show clear efficiency improvement. The conversion rate increased by 4.4% and the yield of LPG and gasoline went up by 4.25%. Economically, the process became more profitable. Net profit rose by 7.19 per ton and the IR increased by 0.92%. On the environmental side, the energy consumption dropped by over 6% and the greenhouse gas emission were reduced by 12.6%. In conclusion, this hybrid model successfully enhanced the FFCC process technically, economically, and environmentally, proving that combining AI with chemistry is effective in real-world industry setting. That's all from me. Thank you.
Hey everyone, my name is Jared, and let's start with some of the key limitations of this study. First, while traditional AI models can analyze large data sets, they perform poorly under non-steady or fluctuating industrial conditions. This limits their real-world application in dynamic environments. Second, even the hybrid models used in this study still rely heavily on lump kinetic models. These don't provide detailed molecular level insights, which are crucial for predicting advanced product properties. Another limitation is that many models overlook feedstock variability. The properties of different raw materials significantly affect reaction outcomes, and current models don't fully capture this. Lastly, there's a trade off between model complexity and solution efficiency. High accuracy models, such as those based on free radical mechanisms, require too much computational power to be practical in many settings. Now, moving on to the future research opportunities. First, the authors highlight the need to shift toward full molecular level modeling. This will enhance accuracy and give better insight into product composition. Second, they suggest building modular and scalable hybrid models that can be adapted across various refinery units and chemical processes. Third, improving model transparency and interpretability is critical. This means creating AI models that can explain how that they make decisions, essential for trust and industrial use. And finally, integrating these models into broader chemical process digitalization efforts can help enable smart manufacturing and real-time decision making. To conclude, the authors introduce a transparent, AI-insisted framework that combines big industrial data with detailed process mechanisms. This hybrid model achieved strong predictive accuracy with R-square values above 0.98 and average errors below 5%. The optimization outcomes was also impressive, improving the conversion rate by 4.44%, increasing high-value product use by 4.25%, and reducing greenhouse gas emissions by over 12%. Notably, financial performance improved too, with net profit per ton increasing by 7.19 dollars, and the internal rate of return up by nearly 1%. Overall, the study demonstrates that combining AI with process knowledge leads to a smarter, cleaner, and more efficient chemical manufacturing.
So let's move to abstract part for critique elements. So firstly, the article explores how artificial intelligence can improve efficiency and control in chemical process using tools like neural network and hybrid models. While the topic is very relevant, the article mostly relies on secondary sources and lacks of real-world case studies and deep analysis. So this makes the discussion feel more theoretical and limit its practical value in real industrial setting. So for methodology part, so we focus on three main points, which is the first one is good sources, deep analysis, and structure. So firstly, the article use good sources from trusted journal, but most of them are secondary sources like reviews. It doesn't include real-life case studies and original research. Because of that, the article feels a bit one-sided and less connected to real-world situation. Secondly, the analysis is in the article is mostly positive. It talks a lot about the benefit of AI in chemical process, like better control and efficiency, but it doesn't really talk about the challenge such as high cost, system risk, or data issues. This makes the article sound too optimistic and less balanced. And lastly, the structure of the article is not very smooth. The topic sometimes jump from one to another without clearly. For example, it moved from process control to water treatment suddenly, Also, some points are repeated, which make it less clear and harder to follow. To sum up, the article has useful information, but it could be improved by using more real-world examples, discussing challenge, and organizing the content more clearly.
In conclusion, we have used a secondary resource to show that the integration and application of artificial neural networks and artificial intelligence in chemical engineering process control should be embraced more by the public. We use a secondary resource, which is an article titled Transparent AI-Assisted Chemical Engineering Process, Machine Learning Modeling, and Multi-Objective Optimization for Integration Process Data and Molecular Level Reaction Mechanisms. We use this article to gather data qualitatively. So in this article, we are introduced to the idea of transparent AI-assisted chemical process control, which is integrating AI to help monitor and optimize future plants. It helps to maximize valuable products such as gasoline and liquefied natural gases, whilst also minimizing unwanted byproducts such as like dry gas and coke. With this, higher yield can be produced, which in turn means more profit. And surprisingly, it does not impact environment. So yeah, that's it.